Hello everyone, this video is about work. It's section 6.4. As I promised, I created this video. So it's about force and work. So as you may seen in the physics before, force is m, that is mass, times acceleration, that is in meter per second square, and that's equal to 1 Newton. So that's Newton's second law of motion. So that is in kilogram times meter per second square. If you have a vertical movement, so this is if you're pushing anything in any direction, but then if you have a vertical movement, you are using gravity, and force is equal to m, kilogram in mass in kilogram, times g, that is gravity, that the unit for that is meter per second square. And again, that's using Newton's law as well. Same thing, just vertical movement. Work is force times distance. So work's unit is Newton times distance, that they also call it Newton meter. But 1 Newton meter is 1 joule, that they show it with J, but then I just write it as, that's how you write it, 1 joule is the work. So if you have it in meter, kilogram, and second square for the force, and you're multiplying by distance in meter, distance is in meter, force is in Newton, so it's Newton meter or 1 joule. So those are the units and the formulas. I will be doing a couple of examples for you to understand the concept and know how to do these problems. Okay. So first example. How much work is done when a hoist lifts 200 kilogram rock to a height of 3 meters? So drawing an image or diagram would really help. So you imagine that the rock has a flat surface, or at least you just imagine that it's one piece, because later you see that if you are taking pieces by pieces out, it will make a difference. So you have the rock at the very bottom, and you are lifting that 3 meters, and you want to know the work done, and the rock itself is 200 kilograms. Okay, and you have a hoist, you're lifting that, you want to know the work. So you say work is force times distance. It's a vertical force, so it's the same thing as, instead of F, I will have mg, so it's m times g times the distance that is moved. The mass here is 200 kilogram. It's already in the kilogram that it should be. G, it's the gravity's acceleration, so it's 9.8, and then meter per second square. So I'm going to write the units at the bottom soon. And then times 3. So I'm going to write the unit so you see that it's matching the formulas that we had. So 200 kilogram, 9.8 m per second square, and 3 meters. So multiplying them out, it's going to be equal to 5,880, and then you just write the unit joule. You could have write it as Newton meter, but then joule is more standard. Okay, so we're going to go to the next example. Okay, an aquarium 2 meter long 1 meter wide and 1 meter deep, is full of water. Find the work needed to pump half of the water out of the aquarium. Use the fact that the density of water is 1,000 kilogram per meter cube. Let me just change that to cube. Okay. So this time is not just one slab of rock or an item, it's an aquarium and it has a depth. So I'm going to draw that picture so to have some image along what we're going to see. Okay, so it's 2 meter times 1 meter times 1 meter. You are pumping half of the water out. In physics, we need to have an origin and we need to define the positive direction. I'm going to define the origin to be top of the aquarium. And then I know that the entire thing is 1 meter. I want to pump half of the water out by the end. So I will take slabs of water and then take that out of the aquarium. I will have so many of those slabs of water. So we're going to see how we're going to deal with that. First of all, one slab of water that we have here. Again, I just calculated for one slab and then add them up using integral. So let's say this is, although this is, you see, is a vertical, so you want to name it Y, doesn't matter. I'm going to name it X direction and I'm going to name it 0 being the top of the aquarium. Again, that's not the only way of doing it. So this is going to be, let's say delta X, which later on I'm going to name it dx. But that means a small piece of water in X direction. So this height right here, it's going to be delta X. So let me just color that, this height right here. Okay, so if I bring that one slab out of the water, although you see the smaller here because I want to just bring up the concept. Let's say this is the slab of the water. It's delta X here, or again, later on you'll see it as dx. And then you know that the length and width is 2 by 1. So the volume of this slab of water, is 2 times 1 times delta X. Length, width times height. Okay, then we're gonna use the distance. So, and what is the unit for the volume is meter cube. In the formula for work, you need to have force, and then force times, so after you find the force, you're gonna multiply that by distance. So work is gonna be force times distance, but let's find the force first. And then force says mg, m is a mass in kilogram. So in order to change the volume to a mass, you need to multiply volume by density. So volume times density will give you the mass. Even if you see it with the units, so the density of water is 1,000 kilogram per meter cube, and the volume of the water is just meter cube. If you multiply them together, you see that for 1 meter cube of water, you have 1,000 kilogram of mass. So that's the formula, and as you see again, the formula m cube and m cube cancels when you multiply volume by density and you remain with kilogram. And that's what we want for the mass. So for that one slab still, we're going to have mass to be volume, which was volume of that piece here, 2 times 1 times delta x, and then times 1000, that is the density of the water. So far the whole thing here was just the m, times g, which we can replace it by 9.8 at the very end, or at any point, in fact. Okay, so if I replace here by 9.8 meter per second square, and I multiply 2 and 1 and 1000 and 9.8, I will get 19,600, and then I also have the delta x. So the work done, or the force done on one slab of water is 19,600 times delta x. But now you need to multiply that by the distance that is moving. So in order to multiply that by the distance that is moving, so from any point to the top, the distance is x. So if you just say right here, for example, if right here is 1/4, you need 1/4 of distance to go up. If it's a little bit lower, whatever it's right here, which is the x value. So in general, work is force times distance, but distance here is defined by x. So it would be 19,600 times x times delta x. Again, that's a work done on one slab of water. So now you want to find it for the entire or half of the aquarium up to here, work done. So you use integral because you need to have all these tiny slabs of water. So you would say 19,600x. Instead of delta x, if we are using integral, we are making these slabs depth very, very tiny. So we name them dx. And then it starts from 0 because the slabs on top will be no distance to move. And then until you get halfway through the aquarium, which you need to move the slab of water, the very bottom one that you are moving for halfway through, with half of distance, or 0.5. So the integral goes from 0 to 0.5. So the answer here would be 19,600 x squared over 2, going from 0 to 1/2. And of course you simplify 2 and 19,600, that's 9,800, and then you go from the difference of top and bottom, so you're going to get 2,450 joules. Okay, next example. You will see the next example in the next video. I try to make sure they're videos, so you'll see the next 2 examples that I'm planning in the next one.